Okay, before I get to combinations, let me give you some more examples of permutations. The number of ways to award the first 3 places in a contest of 10 people. This would be a permutation of 10, and we're awarding 3. So we want to know how many ways we can arrange 3 out of 10. Now, this is a permutation because, first of all, repetition would not make sense because you wouldn't, like, let's say Joe was running in a race. Well, Joe wouldn't get first place and second place, so repetition doesn't make sense. And also, since you're assigning them places, then the order would matter because, Joe could get first place. I mean, if Joe's in the set, he could get first place, but Joe could also be in the same set and get second place or third place. So the order would matter. So there's several different ways. If you took 3 people, there's several different ways they could finish the race. So that the order matters. The number of ways that you can assign president and vice president from 8 people. Well, since you're assigning 2 positions, president and vice president, you want to know how many 2-element arrangements you can get out of the 8 people. And so that would be a permutation of 8p2. And again, repetition wouldn't make sense because you wouldn't assign the same person to be president and vice president. And then the order would be relevant because if you had, let's say you had a person named A and a person named B, well, if you took A and B, A could be president and B could be vice president, or B could be president and A could be vice president. So that would be a different assignment. So that would mean that the order matters. So this has to be a permutation problem. If you wanted to arrange 4 people in 4 chairs, well, that's what I told you before, the special case where you want to know how many arrangements of n people out of n, or n objects out of n objects. So 4p4 would just be 4 factorial, which is 24. And again, you can do these permutations on your calculator. Just find the permutation key. Go ahead and read these special cases, but they're not something you need to memorize. In my class, I just tell the students that it's interesting to consider special cases. This one we already talked about. npn is always n factorial. Okay, now let's discuss what happens if the order is not relevant. In other words, the order does not matter. Let's go back to the baseball team. Let's say we have 12 members on a baseball team. And now, suppose the coach can nominate 5 players. Okay, how many groups could he select? Well, let's select 5 players. Here's 5 players off the team here. Joe, Sam, Bob, Ray, and Don. Now, let's rearrange them. Sam, Joe, Don, Ray, and Bob. Okay, well, wouldn't this be the same 5 players that are nominated? So since I rearranged them and it really doesn't give me anything new, then this can't be a permutation because the order is not relevant in this example. So we're not really concerned about how many ways you can arrange them. We just want to know how many subsets you can choose. So really here we're interested in how many combinations there are. So combinations are basically how many subsets you can get out of a set. Let's use the same 4 letters again here to introduce combinations. Let's say I have M-A-T-H. Let's pretend like those are my sons. Okay, and I've got 2 tickets to the World Series. Now I can only send 2 of my sons to the World Series. So let's look at how many ways I could send them. How many 2-son subsets are possible? Well, I could send M and A, or I could send T and M, or H and M, or T and A, or H and A, or H and T. So that's 6. So I've got 6 different subsets that I could send to the World Series. Now notice that MA and AM are not both listed, because if M and A get to go to the World Series, then that's the same as A and M getting to go to the World Series. So that the order here does not matter. So each of these is a 2-person combination of the 4 letters, or the 4 sons. And a combination is simply a subset, and where the order is not relevant. So the definition of a combination of set of of a set of n distinct objects taken r at a time without repetition is an r element subset of the n objects. So if you look at this, MA is a 2-element subset of those 4 objects. TM is a 2-element subset of those 4 objects. HM is a 2-element subset of those 4 objects, and so on. So there's actually 6 combinations or 6 subsets. Okay, so now let's go back to these numbers and let's see how many 3-object or 3-element subsets are possible. Well, if we list them out like this, 736 would be the same subset regardless of the order that I gave it. So even if I said 376, that would still be the same subset. 764, it would be the same subset no matter what order I gave it. 734 is the same subset. 364 is the same subset. So there's only 4. So here's an example of a combination. Suppose we have to select 4 jurors from 6 candidates. Ask yourself this: can I choose the same juror twice? Of course not. Is the order of the selection relevant? No, because if I choose 4 jurors to be on the jury, then I'm not really concerned about where they're going to sit or anything. I just want to know how many sets of 4 I can choose. Alright, so that means that order is not important. So this would be a combination question. And so now let's get the combination formula so I can answer that. Okay, so the combination formula is similar to the permutation formula, except for NCR, you have n factorial on top, and you still have n minus r factorial on bottom, but you have an extra r factorial in the denominator. So if I wanted to do 6C4, I would have 6 factorial on top, and then on the bottom I'd have 6 minus 4 factorial, and then another 4 factorial. So that would be 6 factorial over 2 factorial times 4 factorial. And I could use my little trick where I write 6 factorial as 6 times 5 times 4 factorial. Then I could cancel it there. And so then I have on top 6 times 5 over 2 factorial, which is just 30 over 2, which is 15. So there's actually 15 subsets of 4 jurors I could select out of 6. And so if you do it on the calculator, it actually will look like this if you use a TI 83 or 84 calculator. It kind of looks strange because you have to put the number in, then the combination operator, and then the second number. And then when you hit enter, it gives you 15. There's different ways to write combinations. You might see it like this, or you could even write it like this. This is actually the same thing, NCR. Each of these questions below lead to combinations for 2 reasons. Number 1, repetition would not make sense. And then number 2, the order does not matter. So how many ways could you select 3 people from a group of 10? Well, basically this is like picking a 3-person committee. So how many 3-person committees are there possible out of 10? Well, the repetition would not be allowed. You can't choose the same person 3 times. So repetition is not allowed. And the order doesn't matter because you just want to know how many 3-person subsets there are. So that would be 10C3. So find the combination key on your calculator or go up here and use this formula to figure out that this is 120. Let's say you were selecting 5 products out of a production line of 15 products, and you wanted to know how many different samples you could choose. Well, order doesn't matter, so that would be 15, choose 5. So 15C5 is actually 3003 if you do that on your calculator. And this is interesting. If you have 5 people visiting and everybody gets ready to leave and you want to know how many hugs are possible if everybody hugs each other, well, first of all, repetition wouldn't make sense because you're not going to hug yourself. And order doesn't matter because if Joe hugs Sarah, then that's the same as Sarah hugging Joe. So the order is irrelevant. So that would be out of 5 people, how many subsets of 2 would be possible to hug each other? And so that would be 5C2 is 10. You can see here you can calculate a combination by hand. 5C3 would be 5 factorial over 3 factorial, 2 factorial, and then you can write 5 factorial as 5 times 4 times 3 factorial. Then you can cancel the 3 factorials, and you just get 5 times 4 over 2 factorial, which is 20 over 2, which is 10. And you can read the next one if you need to. You can pause the video. Here are some special cases again, and again, you don't really need to memorize these, but you might find it interesting that when you have NCN, that's always going to be 1. And that makes sense because it's almost a silly question if I said how many 4-people committees can be formed from a group of 4 people. Well, there's only one committee you could choose, and that would be to just take all 4 people. And so that's kind of interesting, but you can read the rest of them. Now, how do you know when to use a permutation or combination? Well, first, you only use permutation or combination if repetition is not allowed. Then, once you determine repetition is not allowed, you have to decide whether you use P or C. So take a subset from the set, rearrange the subset. If you get something new, that tells you that order matters and it's a permutation. If you don't get something new, order does not matter, therefore you have a combination problem. Look at this example. You have 9 families you would like to invite to a wedding. Unfortunately, you can only invite 6 families. How many different sets of 6 families could you invite? Well, repetition wouldn't be allowed because you're not going to invite the same family twice. So let's choose 6 families. Let's say I choose A, B, D, E, G, H. Now let's rearrange them in any order you want, as long as it's a different order. Is that the same set? Would we be sending the same set of invitations? Yes. Rearranging the order does not change the problem, so therefore we didn't get anything new. So this would be a combination problem of out of 9 families, choose 6. So this would be 9 choose 6, and you could just do that on your calculator or do it by hand to get that there's 84 sets. Let's look at one more example. Then on the third video for this section, I will show you some problems that involve several types of counting techniques. Suppose we have 40 students in a class, and I want to know how many ways I could assign the positions of president, vice president, secretary, and treasurer. Well, repetition is not allowed because we're not going to assign the same person to 2 positions. Let's select 4 students. Let's say I choose these 4 students, A, B, C, and D. So this is president, this is vice president, this is secretary, this is treasurer. Now if I rearrange them, then that means this guy's president, this guy's vice president, this guy's secretary, and this guy's treasurer. So obviously by rearranging them, we're going to get something new. We're going to get a new assignment. So that means order is relevant, so this is a permutation problem. So it would be 40P4, and you can do that on your calculator and get the answer, 2,193,360. Now, if I wanted to know how many ways we could select a group of 4-person committee, if I want to select a 4-person committee, well, repetition is not allowed again, but if I choose these 4 people to be on the committee, if I rearrange them, is it not the same committee? Of course it is. It's the same committee. So therefore, order is not relevant. Therefore, this is a combination. And so you use the combination key on your calculator and do 40C4 and get 91,390. And that's all I have time for on this video. Like I said, I'll do some counting examples on the next video.